Welcome back to module 3 of this unit 1, that is mathematical logic. And we will be talking about how to write down a truth table for a compound statement in this module. Now, before you start with this module, you have to make sure that you know the truth tables for the 5 connectives that we talked about in the previous 2 modules, that is OR, AND, NOT, conditional and biconditional. Because to write down the truth table for any compound statement, we will be using these 5 basic connectives, their truth tables, in writing the truth values. Now let us say I want to write down the truth table for this compound statement, that is P not P or not Q. Okay, this is P bar or Q bar. So we want to write out, so this is a compound statement which involves 2 simple statements, P and Q. And then it is connected by 2 connectives. One is OR and the other one is, this is NOT that is involved here. Okay, so this statement is symbolic form of some statement which has been put into a notation form like this. This is what we know when we write down a statement in notation form like this. And let us say I want to write down the truth table for this. So to write down the truth tables, okay, we break it down into simple statements. There is P here, there is Q here, then there is P bar here, there is Q bar here, and then finally we have P bar or Q bar. So to write out the truth table, what we do is we go in step by step depending on the simple statements that are involved here. There are 2 simple statements that are involved here, P and Q. So I have P and Q. There is P bar that is involved here, so I write down P bar. There is Q bar that is involved here, so I write down Q bar. And finally, after I know what is P bar and Q bar, I can write down P bar or Q bar. Now this is our statement that we are having, and we need the truth values of this statement. Now P and Q are 2 statements. So as we know, they both can take values T and T, T, F, F, T and F, F. Either both can be true or both can be false, or one of them is true and the other one is false. Now to write down the truth values, okay, you have to make sure that you know the truth tables of NOT, because we are using NOT here. So this is the truth table of NOT that I've highlighted here, but then in your mind you should always know these truth tables. Okay, if not, then revise those truth tables first and then come back to this example. The same way I will also need the truth table for OR. So I should have in my mind the truth table of OR, the truth values in case of we have a OR connecting. And this is the truth table that we wrote earlier for OR. Okay. So now, coming back to this table. Now for P, I am writing not P. Okay. So I have to just write down the opposite of P here. So if P is true, I know that not P is false. Here P is true, so not P is false. Here P is false, so opposite of that is true. P is false here, so opposite of that is false. The same way I write down not Q. So if Q is true, not Q is going to be false. If Q is false, not Q is going to be true, opposite of that. Now Q is true, so opposite of that is false. Q is false, so opposite of that is true. So these are the NOT values. After I have got the these columns, now I go to the final column. So I need P bar or Q bar. So I have P bar here, I have Q bar here. Now I use OR. So I should be using OR for these 2 columns here, this column and this column. Now for that I go back to OR truth table. This was the table for OR. I know that OR is true when at least one of them is true, otherwise it is false. So for F and F in OR case, F and F, it is F. When both are false, OR is false. One of them is true, OR is true. For F and T, it is T. So I wrote T here. For T and F, T and F is T. For T and T, it is T. So it is. So this is the truth table or truth values of this compound statement that we were trying to write down. So this is how you should be writing the truth table for any compound statement. Break it down into simple statements, okay, depending on what connectives are involved, and then come to the final column. So basically the steps to construct a truth table is you first set up the columns like how we did for P, Q, P bar, Q bar, and finally the statement that is under consideration. Then we write down the values for P and Q. Then we write down the truth table for not, we wrote down the values for P bar and Q bar. Okay, and then finally we wrote down the truth values for P bar or Q bar. Okay, so in this example, this is how we break it down. Let us say you have another example. You want to write down the truth table for this compound statement. That is P and Q implies P bar. Okay, so again the same way, there are two connectives that are involved here. One is and other one is conditional. So you should remember what are the truth tables for and what is the truth table for conditional. Now conditional truth table is already here to recall. So to write down the truth table for this, okay, we break it down again. So there is P involved, there is Q involved. So first column will be P and Q. Then we'll find out what is P and Q. We need P bar, so we'll find out P bar. And once we have P and Q and P bar, then we will use conditional for this statement. So this is how I write it down. So I have P and Q, so I wrote P and Q. Then I wrote P and Q, I need P and Q. I need P bar also, so I made a column for P bar. And finally to these statements that we need. Now P and Q, we already know it can take the values TT, TF, FT and FF. So recall the truth table for AND. This was the truth table for and we know that AND is true only when both of P and Q are true. If at least one of them is false, then Q is false. Okay. So for T and T it is T, for T and F it is F, for F and T it is F, for F and F it is F. I'm using AND truth table. So this is why you need to remember all those 5 basic truth tables. We write P bar now, so it is the opposite, negation. So if P is true, this is false. If P is true, this is false, P bar is false. If P is false, P bar is true. If P is false, P bar is true. So I have got T and Q, I have got P bar. Now I use conditional. So I use conditional for this. Now conditional truth table is this. For T and T it is T, T and F it is F, for F and T and F and F it is T. So this you should know. So I use conditional truth table for this column and this column. For T and F it is F. So I write F here. For NFF, so F and F it is T. So I write T here. For F and T it is T. So I write T here. And for F and T again it is T. So these are the truth values for this statement. Okay, and this will say is the truth table for this statement that we are trying to write down. Now these were examples wherein we consider two simple statements P and Q. Let us say I have 3 simple statements involved, P, Q and R. Okay, so I want to write down the truth table for this particular compound statement which involves 3 simple statements P, Q, R. Again the procedure will remain the same except that earlier we had only 2 columns, starting columns P and Q. Now we will have 3 starting columns P, Q and R. So again we break it down. So we will need P and Q, a column for P and Q. We will need a column for R bar. And once we have this, then we will find out P and Q or R bar. So this is how you'll form the table. So I need P, Q, R. So there are three statements P, Q, R. I need P and Q. So I made a column for P and Q. There is R bar here. So I made a column for R bar. And finally the compound statement that I am looking at. Now P, Q, R, there are three statements here. Each one of them can be either true or false. So accordingly I'll have T, 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 F, T, F, T, T, F, 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 T, T, F, T, F, 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 T, and F, F, and F. There will be 8 combinations of the truth values for 3 statements P, Q, R. Okay, what I have done is, now this is one part that you already know. You have been writing for 2 cases, 2 statement case, T, 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 F, F, T, and F, F when there were P and Q. So I have repeated the same set again here. This whole part, this part I have copy pasted here. One set with all T's and the other set with all F's. Same way you can write down the truth values for if there are 4 statements. Now in case of 3 statements, simple statement, there are 8 rows. In case of 4 statements, it will be 16 rows and so on. So I need the truth table for AND. There is AND that is involved here. So I recall in my mind the truth table for AND, and there is NOT that is involved here. Okay. So and then there is OR that is involved here. So I have to recall the truth table for OR. Okay. And there is AND. There is NOT also involved here, but NOT is very simple. We know that. So I start writing the truth values. So I'm writing P and Q. So I have to look at P, I have to look at Q and start using AND truth table. So for T and T, it is T, for T and T it is T, for T and F it is F. So I'm looking at T and T, I'm looking at AND. So for T and T it is T, for T and F it is F. So that's how I got F here. For T and F it is F. Now there is at least one F in all this, and I know that AND is false when at least one of them is false. So all these are going to be false. This is false. F and T is false. F and T is false. F and F is F. F and F is F. Next I write down the column for R bar. Now R bar is the opposite of R. So if R is T, its opposite is F. If it is F, its opposite is T. For T, it will be F. For F, it will be T. For T, it will be F. For F, it will be T. For T, it will be F. For F, it will be T. Now I got the column for P and Q, and now I got R bar. And now I use OR. So I have to recall the truth table for OR. I know that OR is true when at least one of them is true. Okay, so for T and F it is T, there is one T. Both are T here, so it is T. Both are false, this will be false. One of them is true, so it is true. Both are false, so false. F and T is T. I am looking at this truth table. For F and T, it is T. Okay, so for F and F it is F. For F and T, is again T. So this is the truth table, the truth values for this compound statement, and this is the truth table, we'll say, for the statement that is given to us. Thank you.